All right, so today we are talking about properties of logarithms. First thing to do, properties of logarithms, we need to remember properties of exponents. So as I look at this, if I take a to the 0 power, Kate, what is the same thing as a to the 0 power? It's 1, because anything to the 0 power is 1. If I do a to the first, Abby, what's the same thing as a to the first? Just a. That's a silly one, but it's just a. Okay, a to the m times a to the n. Kara, what do I need to do with my exponents if I'm multiplying their bases? You add them. So it's going to be m plus n. It's easy. Okay, Matthew, if I got a to the m divided by a to the n, what's that the same as? A to the m minus n. We just subtract our exponents. Okay, then I've got a to the m n. A to the m n. Ella, what can I do with those two exponents? Multiply them, so it's just a to the m n. A b to the m. Everybody got an idea on that? Max? A to the m times b to the m. Good. We just both things get the exponent there. And then number 7, a over b to the m. Sophia, what do you think on that one?
A to the m over b to the m.
Yep. Those are properties of exponents. Those are things you learned back in Algebra 1 and Algebra 2. Hopefully nothing too crazy with any of that, but it's stuff you need to know. A reminder that a logarithm is an exponent. It is the inverse of an exponent. So what that means is it's going to have the same properties of exponents are going to be true with properties of logarithms. Okay, so up above, we multiplied two bases together. And when you multiply the two bases, we could add the exponents. Well, if we have arguments that are being multiplied together, we could separate those two things and add two separate logs of that same thing. Okay, that is the same component. So just like when we multiplied, we could add, we're multiplying, we can add. Okay, properties of exponents apply. All right, we could work through all those. I think the easiest way to do it is just see some examples. Okay, so what we're doing first here is called expanding the logarithmic expression. Okay, we're expanding. When you think of the word expand, what do you think of? Getting bigger. We're getting wider. We're getting longer. Okay, we're expanding. Okay, so what we're going to do here is we're going to take one complicated log. The argument of this logarithm is going to be fairly complicated, and we're going to rewrite it into several simple logs. All right, so looking at number 1, I've got log base 3 of 5x to the 4th. And this takes some practice. Okay, this is not something you'll get the first time. But how many parts of that argument do you see? Show me your fingers. How many parts do you think you see of that argument? And this is a bad question. And you're going to be wrong the first couple times I ask it. The answer is 2. Okay, we have 2 parts. We've got the 5 and we've got x to the 4th. How many parts are being multiplied or divided, I think would be the better description. How many different things are being multiplied or divided? There are 2. All right, so because there are 2 parts to this logarithm, I'm going to write log base 3 2 times. Because I'm going to separate it, because there are 2 things being multiplied or divided, so I'm going to separate it into 2 logs. Once we've done that, we are going to take each part that's being multiplied or divided and write it with that log. So this first one, I'm going to put the number 5. With this second one, I'm going to put the x. It did have a 4th power. It had a 4th power. We're not going to put the 4th power right there. Okay? We have a logarithm, which is an exponent, and then we have an x to the 4th power, which is an exponent. What did we do up above when I had an exponent and I had another exponent? What did I do with the 2 exponents? We multiplied them. The same thing is going to be true here. I've got an exponent, log base 3, and 4, which is an exponent. So we're going to multiply them. So what we're going to do is we're going to take this 4 and we're going to write it out in front. It's 4 times that. I'm multiplying by that base, or by that new exponent. So that is another thing we can do. If we have an exponent, we can write it out in front. There's my 2 logs. They're simpler now. Now all we have to decide is what sign goes in between. Do I put a plus sign in between or a minus sign in between? The 2 things were being multiplied, so if they're being multiplied, what am I going to put? Plus done. That is my expanded logarithm. This right here is the same thing as this right here. It's just written in a different way. Okay, we expanded the logarithm. Questions on number 1? Number 2, log of x divided by yz. How many things do you see that are being multiplied or divided? Show me with your fingers. How many different parts do you see that are being multiplied or divided? Show me with your fingers. There's 3 here. There's 3 because you got to think all the different parts. If they're basically, if you could put how many times can you put a multiplier and divide? There's 3 things. Okay, they're divided and you're multiplied there. There's 3. So what is a log? 3 times. Log 3 times, and we're just going to separate it into the 3 parts. Okay, so my first part, I'm gonna throw an x with it. My next part, I'm gonna put a y with it. And then my last one, it's a z. Those are the 3 elements that are being multiplied or divided here. Everybody good to that point? That was easy. There's no exponents. All we have left to do is decide if it's a plus sign or a minus sign. Okay, but in between the log x and the log of y, thumbs up if you think it should be a plus sign, thumbs down if you think it should be a minus sign. Thumbs up if you think it should be plus, thumbs down if you think it's, why do you think it's going to be minus here? You're dividing. If you're dividing, you subtract the exponents. We're dividing, so we subtracted the 2 exponents when we split them up. So that is a minus sign. Now be careful on the second one. This is the one we miss. Log of y and log of z. Thumbs up if in between those two you think you should put a plus sign. Thumbs down if you think you should put a minus sign. It is a minus sign. Anybody have a good reason for that? Sophia?
I just have a question.
Yes, ma'am.
If you had put like the log y and z in parentheses, could you put plus in the middle?
Correct. Yeah. Okay. So it's going to be a minus sign. All right. And Sophia just kind of brought up this point and understand why maybe a little bit better. You can do this. It's log of x minus. And she said, well, what if I put that in parentheses? Now we're taking the y times the z. Yeah, that's right. That's what we did. But where is it? It's on bottom. I'm dividing by it. It's a minus sign. Okay. So you could do that. But if I wrote it without parentheses, what would I have to do with the minus? I would distribute them. And so both of them would be negative. So you can do that if you want. Don't do it that way. The easier way is this. When you look at this problem, it's very simple. Is your element in the numerator? It's plus. Is it on bottom? Is it being divided? Then it's minus. Okay, so as soon as I see that z is on bottom, oh, cool, it's a minus sign because you are dividing it. You are dividing the overall element by that number. Questions there? All right, let's look at number 3. Natural log of x cubed times the square root of x plus 2, all divided by 2. How many different things? Now pay attention. How many different things are being multiplied or divided here? Show me with your fingers. How many different elements are being multiplied or divided here? Good. There are 3. There are 3. I've got this x cubed. And it is times all of that. That is all one element because it's all together. Okay, the plus sign is great, but it's there. And it's all divided by 2. The tricky part here is we don't want to leave this as a square root of x plus 2. That's funky. Okay, instead, we could rewrite that as x plus 2 to what power? The 1/2. Okay, that is the same thing as 1/2. With your neighbor, take a second here and try to write that into 3 separate logs. See what you can do with that. Go. Hang on. Good. 3 natural log x. If it's x cubed, he wrote the exponent out in front and then wrote an x with that part. Good. Next one. Haley, what'd you put with the next element?
We did 1/2 natural log.
Natural log of x plus 2. Great. Putting that x plus 2 in parentheses is incredibly important. If it's not in parentheses, it is not the same thing by any stretch. Okay, got to throw that in parentheses. Okay. Last one here. Natural log. Sam, what'd you put for that one? Natural log of 2. That's easy. I don't know why I called on you. That's too easy. All right, good. Let's look at this one. In between these two, in between the x cubed and the 1/2. Thumbs up if it's plus, thumbs down if it's minus. It's plus. It's being multiplied. It's on top. In between the second two, thumbs up, thumbs down. Thumbs down. It's minus. Questions with that? Let's just talk. This is completely off topic, but this is from yesterday's quiz. Okay? On yesterday's quiz, you got something like this. x squared plus 5 over x squared plus 1. The amount of times that I had students do things like this is bad. You cannot cancel that. Okay? You cannot cancel that. Here's why. Let's say I gave you 2 plus 3 divided by 2. That would be 5 halves. Everybody agree? If you do the canceling that you say, oh, I got a 2 on top, I got a 2 on bottom, and I cancel that, what does that now get me? 3. Is 5 halves the same as 3? It's a different answer. You cannot do that. When you have a fraction, if there are plus and minus signs, you cannot cancel unless you are canceling out a factor. Okay, so think back to what we did in our rationals chapter. We had 3x plus 1 over x plus 1. Now I can cancel out an x plus 1 because it's an entire factor. But if you see plus or minus signs in a fraction bar, do not cancel it unless it's a factor. Okay, it gets you a different answer. We had that a whole lot yesterday. I just wanted to bring it up real quick. Questions there on 4? All right, let's go back. That was just me freelancing. Here we go. So on the front side, we expanded. We said expanded means get bigger. On the back side, we're condensing. What do you think condensing means? Smaller. This is why we expand. Expanding what we did on the front side, it's kind of dumb. There's not really a good purpose for it. But on the back side, condensing is going to help us to solve. And we're going to use this tomorrow. But by using our condensing skills, we are able to then solve some pretty complicated things. So this is why we do what we do on the front. We're going to make many different logs into one log. Okay? So as I look at number 5, it says log base 3 of 4 plus log base 3 of x minus 2 log base 3 of y. We are going to rewrite that into a single log. So we're going to rewrite it as just log base 3. And then we're going to put the different elements together. Okay, my first element is just a 4. So cool. I'm going to write a number 4. My next element is an x. How is that x going to be related to that 4? Multiplied, because there's a plus sign there. So it's just 4x. And then my last one is minus 2 log base 3 of y. 2 log base 3 of y. What does that 2 actually mean here? Squared. It's an exponent. And where is it going to go if it was a minus sign? On bottom. It's y squared. That's my condensed logarithm. I took something fairly complicated, made it simpler. They're both the same. The bottom one's going to allow us to solve it a lot easier. Questions on 5? On number 6, I made a little typo here. I can't condense these two the way they're written, because one is log base 2, the other one's log base 3. Okay, so we wouldn't be able to condense that. But let's act like I wasn't bad, and this actually said 3. Condense that. Okay, take a second with your neighbor, condense it first, and then once you've condensed it, simplify it a little bit. See what you can do with that. Go. Let's go here. We're trying to simplify, so we are trying to condense it as a single logarithm. So it's log base 3. Obviously, my first thing is just going to be x. Megan C., what'd you put next? So I got an x, and then what? Good. Times x cubed, because we got the 3 there. We can move it back there. Kendall, what'd you put next? X squared on the bottom. On bottom because it's divided, so it's x squared on bottom. And then my last one. Thumbs up if you think it should go on top. Thumbs down if you think it should go on bottom. It's positive. It goes on top. So, good. It is y, and what's the y going to be? Square rooted, because it's a 1/2 power. So this is fine. We could obviously simplify this even more. On top, I've got x times x cubed. So what is that really? X to the 4th, and it's divided by x squared. So x to the 4th divided by x squared, what would I do? X squared. That is the real answer. Okay? And then think about doing that. That should make a ton of sense that I'm left with x squared. Because look what we had. Log base 3 of x. And then you had 3 log base 3 of x's. So how many log base 3 of x's do I have currently? 4. And then I subtracted 2 of them, which gets me 2. Oh, yeah, that's what I had. Okay, it's x squared. And so just thinking of it in terms of that should make sense as well. Lydia? Yeah, we wouldn't do that very much, but yes, we can always simplify down. Try 7. Try 7 with your neighbor. See what you can do there. All right, here we go. We are writing this as a single natural log. Aaron, what'd you write first here? cube root of 8 because it's 8 to the 1/3 power. What is the cube root of 8? 2. So we could just write 2. You wrote cube root of 8. Wonderful. Okay, but we're just going to simplify it to 2. Okay, then it says minus 1/2 natural log of x minus 2. Herman, what'd you put for that one? Good. Square root of x minus 2 on bottom because it is minus. It goes on bottom. And then Aaron H., what about natural log of 1? Yeah, this is just 0. So you could do this a couple different ways. You could just say, oh, the natural log of 1 is 0. And if I'm adding 0 to anything, does it really matter? No. If I didn't do that, what would I be doing with that 1? Multiplying it on top. So, oh yeah, that didn't do anything either. So you could treat it either way. Well, hey, I'm multiplying by 1, didn't do anything. Okay? Or I'm adding 0, it doesn't do anything. Either way, we're fine. This is our final answer. Questions on 7? All right, let's look at this last part. So this last part is called the change of base formula. This is something you need, okay? Especially if you don't have a good calculator. If you were to do logarithm problems and you only had your iPhone, you got to do it this way, okay? If you have a nice graphing calculator like we do, we can solve it the other way, but we'll show you how this goes. Change of base formula. I hate that it's called the change of base formula because we do changing bases with our exponents like we did yesterday. Like we wrote 4 as 2 squared. That was changing the base. Well, this is different, but the same idea. Okay. So here's what it says. Basically, it has a whole bunch of letters, but it means this. If you had the log base 3 of 5, if I just said, hey, let's do the log base 3 of 5, the way you could get that in your calculator is to take the log of any base, pick a number, 2 of 5 divided by the log 2 of 3. This is the same as that, log base 2. It didn't matter what base we just said. You could have said any base in the world. We could have done 10. So we could have not written anything at all. Could have just been log of 5 divided by log of 3. Could have done log base E. It doesn't matter. Okay? So in other words, we are doing this. If I wanted to solve this log, you take the log of the argument divided by the log of the base. Or the natural log of the argument divided by the natural log of the base. That will get us the answer to this question. Okay? Let me show you why. All right, so we're going to do a little bit different stuff. Let's rewrite this problem, y equals log base a of m, in exponential form. Okay, so in other words, I'm going to get rid of log base a. How would I get rid of log base a here? Raise it to a power of a. Boom. A to the y is equal to m. So I just rewrote it in exponential form. Now, let's get y by itself. Which is kind of dumb. We just got, why do we do getting y by itself? We just rewrote it in exponential form. It's fine. Just believe me. How can I get that y out of the exponent? We could use log base a. But in fact, we could use log base anything. I don't care what the base is. I'm going to say log base b. I'm going to take, and whatever I do to one side, I got to do to both. Log base b. Because it doesn't necessarily matter that it cancels out. So far, every time we said, oh, log base a and a, those two things cancel out. And so you're left with that. But that doesn't really matter. Because what can I do with this y if I just took the log of that? I can put it in front. Because I've got an exponent here and an exponent there. And what do we do with those? We multiply with them. So I could take that y and put it in front. So it didn't matter what the base was. Because I can still write it in front no matter what. And if I want to get y by itself now, what would I need to do to finish? Divide. Y is equal to the log base m, or log base b of m, divided by the log base b of a, the argument. Or, I'm sorry, of the base. Okay, that's proving what we just did. Okay, break out your calculators. Let's show you what we just said. If you want to evaluate the log square root of 5 of 8 in your calculator, by what we just learned, you are going to take the log of the argument divided by the log of the base. Let's just use the common log. Okay, so that means we're going to take the log of 8 divided by the log of the square root of 5. Log of the argument divided by log of the base. I always say this. Hey, the square root of 5 is in my base. It's in the basement, so it goes on bottom. Okay, it's going to be divided by that. So in my calculator here, I can do the log of 8 divided by the log of radical 5. I type it in, I hit enter, boom, I get 2.584. We used log, but we could have used natural log. Let's use natural log instead. Natural log of 8 divided by the natural log of radical 5. Oh, look at that. I get 2.58. Or we could type it in the other way. Your calculator, if you're using a graphing calculator, can do this as well. Okay? On your calculator, hit alpha and then F2. Gets to our secret menu. Alpha, F2. Which one of those do you think we're going to use here? Log base, number 5. Okay, if I use number 5, now it lets me type in the base. Okay, if I just hit the log button, it's base 10. But if I use that log base button, alpha F2, now I can go second square root 5 of 8. And it gets me that. Questions on what we just did? Yes, sir. Yeah, but that's not as fun to hit the math button. I know that. You can hit math, and then you can go, what is it under? Number? Oh, it's up, and then it's not numeric solver. A, I got you. You can go to that one, and then type it that way. But that secret menu, way less buttons. I win. At 1, 2, 3. I use 3 buttons. How many does it take you to do it the other way? That's way too much. You have to memorize that it's alpha A. I can see it on mine. Mine's way better. Nope, sorry, tough. I win. Okay, let's go in our calculator. The next one. So we found that number is 2.584. Then it says let's graph it. So some of us were having issues graphing logs. You can graph them in your calculator. I know we haven't done that a lot yet, but we can. Log base 4 of x minus 3. Okay, so you could go alpha F2, number 5, or math alpha, and do log, what are we even graphing? 4x minus 3. All right, 4 and then x minus 3. Okay, and then I could hit zoom 6 to look at that picture. There's my graph. Know that that's not a good picture. Your graphing calculator is not doing a great job here because it gets so vertical right there that it doesn't graph it right. That thing extends down forever because a logarithmic graph goes all the way down. That's why I like Desmos better. Okay, because I can see stuff better. It doesn't get randomly cut off. But you could also graph this thing as this log, just regular log, of x minus 3, close my parentheses, divided by the log of the base. So log of the argument divided by log of the base. Watch my screen. It's color-coded. Hit graph. The red line went right on top of the blue line. Okay, because it's the same thing. Questions on something we did today?